Welcome back to our channel. Question number 2. A and B is about the uncertainty. Fairly common question, so pay attention to uncertainty, percentage uncertainty of adding things together, or multiplication and division. This is a common question. Okay, first A. Okay, don't look at the question first. Look at A. Okay, suggest why some values of the experiment are stated without uncertainty. Then look it up. You know what is it? Uncertainty. Some without, some with. Some has uncertainty. 1 degree Celsius for the final equilibrium temperature of water, the average. Okay. The other didn't. Why? Why? Because we got this data from digital meter, right? So the reason is they are measured from digital meter. So we don't need to state explicitly the uncertainty. Why? Why? Because you know if they are from the digital meter, the uncertainty equals what? Equals the last digit 0.001 or 0.00001, okay, over 2, okay? Right? You remember the rules, okay, last digit divided by 2, okay? So you don't need to state the uncertainty, you can calculate it from the thing, okay, last digit, make it a 1 and then divide by 2, okay? So it's the answer for A. For B, fairly complicated, but just 1 mark. Sometimes I think it's too mean, but we still need to do it. Find the percentage uncertainty in the temperature change of the water delta T. So first of all, you need to find the temperature change, right? So temperature change of water. So you need to look at from the question, okay, water initially container have water. Initial temperature of water is 45 degrees Celsius. And then add the ice, right? And then stir it and then to equilibrium. So it is initial and final temperature of water. So we need to find it out first. So 45.0 minus 20. So it is 25 degrees Celsius. And then you need to find the percentage uncertainty. So you need to find the uncertainty of the measured temperature. You have 2 parts, right? Subtraction, but the uncertainty add together. So the uncertainty of delta T, you need to add them together. For 45.0, the uncertainty is, remember, last digit 0.1 over 2. And for the 20, it stays explicitly 1. So add them together, remember, uncertainty always accumulates, so it's 1.05 degrees Celsius. After you're doing these 2 steps, you find it fairly straightforward. Percentage uncertainty. So you get percentage uncertainty. Remember, write some description of what you are calculating. To just write the equation. Okay. So it is uncertainty over the measured value times 100%. Before calculate it, look it once more time. Am I right? Yes, we are right. Okay, then the answer 4.2%. Okay, so remember the percentage error should follow the least accurate part. Okay, so one is 3 significant, one is 2 significant. So you should state it clearly. It's as 2 significant. You got it? Well done.